everyone, and welcome to AI in Architecture, Generative Solutions in Revit, AutoCAD, and Fusion. At today's webinar, we will clear the fog about buzzwords, AI, machine learning, immersive design, generative design, etc., and bring the hype down to earth. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Phil to revisit a step or ask any questions. This is your time, and we want you to make the most of it. And in the upper left-hand corner, we will have links to our social media and website. Also, we have our YouTube channel there, so you can check our webinars at the end. We always post it there. I don't know if I told you, but my name is Juliana and I work in marketing here at MicroCAD. And today's presenter is Phil Marshall, our applications specialist. And without further ado, we'll pass it on to Phil. Hi, Phil.
Good morning. Let me share my screen. So now you should see a slide that says AI in Architecture 2.
That's right.
Well, welcome to our webinar, and we're going to be talking about AI. I've appended the 2 to the title of the podcast because it's just a couple of months ago I gave a very presentation on exactly the same subject to an AIA group in Boston. But there's been so much that's changed in just the last couple of months that I felt it was necessary to revise and present it again. This is undoubtedly a hot topic for all industries, but the creative requirements in architecture make it especially relevant. And it's still new. Only in the last year, the production quality AI systems began to be commercially available, and now people are using them more and more. So let's talk about what it is and how it works. So last fall, an architect asked AI to design some skyscrapers for him, and this is what it proposed. Highly creative, imaginative, probably not what was expected. This was generated by a machine, not an undergraduate studio. This is AI magic. Well, except it's not really magic here. There's the software that was used incorporated a technology called machine learning, which browsed millions of images and found some common patterns. With the help of data scientists, it learned what distinguishes an image of a building from an image of a dog and applied keywords to those patterns. Then our architect, Manas Mahada, provided the software with a list of criteria. Perhaps he used residential, futuristic, towers, symbiotic, eco-friendly, freeform, walkways, rectangular, streets, and appended some of these criteria with emphasis. So symbiotic and eco-friendly were stressed, rectangular was suppressed, and no streets were allowed. And the software found matching patterns, interpolated among the pattern swatches, and filled in the gaps, creating a smooth, holistic image. There are several image generation packages out there now that work with neural networks and machine learning to do pretty much the same thing. Stable Diffusion was released in 2022 and quickly became the darling of image boards. Midjourney is an independent research lab which created the software with the same name. A beta version of Midjourney was released in March 2022 to collect images from Twitter users to help the system's training. And DALL-E 2 is a product OpenAI. It is based on the same GPT-3 neural network deep learning system that powers ChatGPT. And you've probably all heard about ChatGPT. Yet that's a text generation AI system that had 100 million active users in January, making it the fastest growing consumer application in history. The first release of DALL-E for graphics was in January 2021. And unlike the other developers, OpenAI plainly says that their intent is to create a system to solve human-level problems using artificial general intelligence. But they agree that we aren't there yet. These are organizations who are working on tools suitable for use as AI in architecture. There are incredibly complex systems, but they're not magic. No magic, but a lot of setup work by researchers to build the database and keywords. DALL-E has 12 billion keywords. Not magic, but a lot of algorithmic processing provided by the software developers. Not magic, but also not true AI. And these are of limited value to architects today. They generate complex images, but only images, no knowledge of what the images represent. So they can't be used for downstream purposes like BIM. The results are highly dependent on the source material the database used as reference. For example, if the database only included timber structures, that would be all you could get, which is why the developers are always adding to their databases. Using these systems requires a lot of iteration. Did eco-friendly really do what I wanted? Maybe I should try sustainable instead. Maybe I add more emphasis on tower to coax the system into creating taller structures. And there will be problems with the resulting images because they are stitched together from the source material. You might get a balcony floating in space or a door where there is no wall. Human figures are particularly problematic. All three systems tend to create images of people with extra fingers or an arm growing out of their chest. And if you see a glitch, there's no way to tell the system. So although the system can learn from the millions of images in its database, it doesn't learn from its own creations, at least not yet. What is in the systems now are examples of images that are wrong, like hands with too many fingers, and keywords are associated with that image. So in Stable Diffusion, for example, you can use the keyword extra digits with strong negative emphasis, and that would reduce the likelihood of creating them. But the developers are the ones doing that, not the end users. The user is probably used to design tools where they can tweak the design by pulling or pushing on a line or a surface. But with these tools, all you can do is change the text keywords and the emphasis. Oh, and by the way, if you run the systems a second time with exactly the same keywords, you'll get something different. So there's no expectation of homing in on a target, getting closer each time. Each run is independent, and the search algorithms are so complex it might as well be random. And after you have run dozens or hundreds of images, refining the keyword choices, you still won't have an image that is suitable for professional work. Photoshop will still be required to touch up and finish the results. That doesn't say that these systems aren't fantastic or useful. They can allow you to explore design themes, change residential to commercial, for example, and see what happens. And if you're willing to put in the effort, they create amazing presentation material. Perhaps the greatest benefit is it blows away any creative roadblocks, generating ideas that might never have been considered otherwise. And there are progressive architectural practices that have incorporated AI usage into their conceptual design stage. This allows human designers to use the AI to generate concepts that they wouldn't have thought of otherwise. And some practices are building databases of their design work so that the AI systems can reference their earlier work, meaning that newer designs will follow the branding of previous designs. And our Australian architect studio Snoop introduced their AI designer named Tilly Talbot at a trade show and displayed work that Tilly created. But for most practices, the technology just isn't ready yet. So what would you as architects want from an AI system in order to be useful? First, that database of images has to be replaced with a database of objects, billions of them. The objects should include full BIM models of campuses as well as component objects. The metadata characterization should include the functional and topographic relationships amongst the objects. So a door is associated with a wall, assuming the wall means any near vertical surface. Second, the users have to provide a value function that would inform the AI what is good and what is not. This might be something like more square feet is good, reduced width of corridors is bad. Obviously, there has to be specificity and granularity in such a value function. and the users have to provide any site limitations which the AI wouldn't know about otherwise. The developers of such a system would need to have algorithms in place to check what is feasible. Here I'm using the word feasible to mean relationships that come from the objects in the database itself. So, for example, it isn't feasible to have a door where there's no wall. And the system has to be able to rank solutions by goodness, where the value functions are provided by the user for this specific building. Structural requirements, architectural criteria, and building codes all need to be implemented in the algorithms with the ability to tweak as necessary. Finally, the output would be a BIM model at the level of detail needed for that particular project. If implemented properly, this result could be a massing study, or a conceptual model, or a space planning model, or even MEP layouts or detailed design. This would be the AI in architecture that would be the ultimate. But it's unlikely we'll reach that goal before the world changes enough to make it obsolete. If you think about embedded mind reading devices, which would make AI redundant, then we've got a long way to go before this becomes useful in a day-to-day basis. In the meantime, any partial implementation of AI for architecture doesn't mean we'd need fewer architects. These tools are just another tool in the toolbox for particular areas. Number one, working with concepts and looking at variations of a theme. And number two, performing routine work. The creative work, the finishing, will still require and reflect human input. So let's talk about what's doable today and how you might use it. First, we need to define our terms. True AI understands objects, properties, and interactions. True AI is capable of making decisions about structure, content, and connectivity based on intelligence embedded in the objects in its knowledge base. There are no true AI systems usable in architecture today. Machine learning is the process of pattern recognition from a large knowledge base working from user-provided keywords. True machine learning would include a feedback loop. Current machine learning systems are only viable for text and flat images. Generative design is where the computer generates thousands of options, provides some filtering based on objective functions that the user provides, and then presents the most likely solutions for the user to choose. There are limited generative design systems in place today, including in Revit, Inventor, and Fusion. And lastly, design automation. Design automation uses tools, usually programming tools, to solve a particular problem that's well defined. If you think about automatic sizing of HVAC systems in the building, that's an example. These tools have been around for a long time and are mature technology. So now we know what true AI isn't here yet. What can we use that's available? So text-based AI systems like ChatGPT, they are being used today for specific purposes in many studios, and designers are actively extending the potential applications. Second, Revit has third-party rendering add-ins that provide further user control on the rendered image. Third, Revit has generative design built into it, which has been available for several years and is getting more and more capable. And lastly, design automation tools. They came with the first of the CAD tools, but they're now becoming more accessible to the average designer as opposed to programmers. So let's get a little deeper into ChatGPT. Currently, designers are using text-based tools like ChatGPT for a variety of support functions. With text-based tools, you can ask a question, and the system scans its database to find the relevant answers. This usage for research, cost estimating, and code compliance is getting to be pretty common. Less common, but gaining ground, is using ChatGPT's functionality to generate code. A user could submit text directing ChatGPT to create Python code to perform a task. For example, a user might enter, generate Python code to convert all doors on stair towers to 2-hour fire rating. Then ChatGPT would find all the references to the create a Python code to find all of the doors adjacent to stair towers, find a property that is the fire rating, and make the changes necessary. This kind of usage requires a human to convert the Python code into to reference real Revit objects, but it still could be faster than writing the code yourself because you just plug the Python code into a Dynamo script. Another use of AI with Revit is to supplement Revit's rendering. There are multiple third-party add-ins available to take a standard Revit image and manipulate it. These tools typically use text input to describe the setting or background, lighting, atmosphere like fog or clouds, materials, and finishes. The result is an image which reflects both the Revit structure, so you have the geometry all correct, and the AI, the rendering add-in, unique representation. It's currently implemented. Generative Design lets the user specify a number of objective functions and boundary conditions, and then the system creates thousands of design alternatives. These are filtered to get rid of the clearly inferior options, and the remaining small number are presented to the user, who can then choose one. This technology has been used for many years in designing mechanical components, where the options are also tested for engineering performance. Here's one example. So there was an example from the manufacturing world where generative design allowed the Airbus designers to try many different options, come up with ones that met the stress requirements and minimized the weight. And for the last several years, generative design has been available for the AEC designer. These have typically been implemented by creating a small set of scenarios pre-configured for the user. For example, one scenario might be placing objects in the room, tables in the restaurant, or desks in an office. This example might try to find the optimum placement to get the most objects in the space while minimize distance to core utilities and providing everyone with window views. Curated options are shown in the top panel up here, and the objective functions like the number of tables, percentage of window views, distance to exits, and so on are shown in the bottom panel down here. The user could then query against the set of options to decide which one is best. Let's see what that might look like. So generative design in Revit comes up with pre-configured scenarios like placing objects in the defined area. So the objective is to maximize the number of desks. You can also constrain the solutions by measuring the amount of window views and the distance to an exit. Then generative design generates thousands of options. After generative design has completed the study, it shows the best possibilities in the panel at the top of the screen. At the bottom of the screen is how each solution measures the objective function and the constraints. To explore the solutions further, you can select one of the measures, like distance to exit, and see how the solutions rank. Alternatively, you could use a scattergram to see how each solution fares in each measure. Once you're done, you select the solution you want and click Create Revit Elements. Now these are now added to your Revit model as objects just like any other Revit object. So using generative design allowed you to optimize the placements of desks in the room while constraining the solution with window views and distance to exit. Here, generative design was a tool that helped the designer make the trade-offs inherent in any design when you have multiple constraints. Design automation tools are included in virtually all authoring software, usually in the form of a programming API. But Revit has Dynamo with a graphical user interface. This makes it a lot easier for a designer to use, not necessarily a programmer. The algorithms you use need to be created for the specific task at hand, but they still can save considerable amounts of effort for minimal investment. While you can create these yourselves, there's an active, free sharing environment for Dynamo and an extensive third-party marketplace to save you development effort. Consultants are also available to perform the implementation for you. The list of example applications shows the breadth of tasks suitable for automation. They range from pure design calculations to object placement, checking against code or standards, and data transfer from to a BIM database. Text-based AI, rendering add-ins, generative design, and design automation, all of these tools are available today. If you're not yet taking advantage of them with Revit, it's easy to get started. You should have an appointed leader to organize and implement the tools. They will become a cheerleader to encourage all the architects and designers in the practice to use the tools available and suggest new ones. The coordinator would establish standards, policies, and nomenclature to ensure that any tools developed are able to be used by everyone. And as the people most affected by productivity and quality benefits, project managers should be made aware of these tools, not because they personally will use them, but rather because they can direct their use on the client's projects. But we've seen that the AI field is changing quickly. There are things you should be looking out to see when it may be ready for the next breakthrough. One signal would be the text generation AI field. Like I said, in January, 100 million people using ChatGPT, and that's continued to grow and grow and grow. We need to be looking for when the text-based systems can actually deliver true AI for text, which would be human reactive and able to be used in human conversation. We're not far away from that now. If they can deliver true AI for text, then moving that technology to structured data like BIM models would soon follow. Another indication of AI readiness would be the release of near AI solutions tailored for specific BIM problems. If software developers can deliver solutions to address object-oriented topological areas like those shown, they will be well on the way of delivering a more full functional AI system. Note I'm using the term near AI to mean a system that works like true AI but doesn't have the full knowledge of the objects. They would rely on human input to verify correctness and completeness of the solution. Finally, to make any true AI system work for BIM would require a huge reference library of BIM models. If we see developers consuming production BIM models, breaking them into patterns and assigning metadata to the components, then we can expect the resulting database to be part of an AI system. In the same fashion, if any professional organization starts to define data structures for AI use or offers libraries of BIM objects with metadata, then we would know that the databases required for true AI are coming soon. Any of these indications would be a signal for the architectural practice that wants to be on the leading edge to get involved in the AI marketplace. So we talked about the buzz around AI systems in architecture. We defined the different kinds of systems and recognized that none are true AI yet. But we also highlight several tools, including generative design and design automation, that are tools available now with Revit that will help your design productivity and set the stage for when near AI systems are released. It's an exciting time to be in this field. So I'll try to answer any of your questions now.
Thank you, Phil, for that wonderful presentation. And yeah, as Phil said, you can ask a question on the left-hand corner. And the first question I see is, are all of these AI software packages free?
Yeah, so all of the ones that obviously being a new marketplace, these software developers want to get users out there. So OpenAI as a company, Stable Diffusion, and Midjourney are all of they have free versions available. Now those free versions are limited in some ways. They may not have some full functionality, or they may be limited in how many um, runs you can make in a day. But definitely the idea is they want to get people involved and start to use their products. So all of those are free. The generative design and the Dynamo's capabilities are free within Revit. So if you have Revit, you have those capabilities. You may not be using them yet, but you have them already available.
Got it. Thank you, Phil. Second question. Revit has a couple of scenarios. How do I create more?
And that sounds like that's coming from someone who's a Revit user who's been working with the generative design software. And you're right that Revit does have a couple of scenarios set up. I think there's 3 or 4 of them pre-configured for users. If users want to create new scenarios, so if, for example, you don't want to place objects in the room, what you want to do is optimize the stair widths over multiple stair vertical circulation channels, then you as the end user can take the typical example of the objects in the room scenario and just change the objective function, change the rating, and change the algorithm of how you generate these, which is fairly simply done. It's a Dynamo package. So you go into the Dynamo package and just tweak it to do exactly what it is you want. This like I say, it's reasonably easy, but it does require you getting into Dynamo, so you do have to roll up your sleeves and dig into the details. But the scenarios that Autodesk provide are well documented and they're structured to allow extension for new capabilities. So to create your own scenario, it's not a huge effort. It does require you to be fairly knowledgeable of Dynamo.
Thank you, Phil. And the next question we have from Steve is there any AI out there that works on a construction document level, such as coordination of door schedule slash hardware?
Yeah, the simple answer is no. Um, there's no AI that will automatically scan a PDF set and generate schedules from it. However, there are existing systems that will scan drawings and try and establish patterns. So if it finds the same pattern in multiple drawings, it would say, well, whatever that is, then I found 3 more of those same kind of things. And it could schedule them, but it still would require for the user to say, yeah, that shape that you found, that's a door, and put it onto the schedule as a door. So that I don't know of any intelligent systems that will able to scan drawings, PDF drawings like that. I What I would do is if I had a set of PDFs, a CD set, then I would go back to whoever created it and say, you probably have a model that's more intelligent than these drawings. Let's look at that model and extract the data from the model. So that's a case where swimming upstream might give you more information.
Thank you, Phil. And another question from Brendan. Can you repeat the names of the free AI tools? I caught Midjourney but missed the others.
Sure. So the 3 that I referred to, which is not all of them out there, but these are the 3 that people are using for image processing. Stable Diffusion has been around for a while. It's by an organization called CompVIS. Midjourney, which has been around for a couple of years, and that comes from a research lab called Midjourney. And now E2 from OpenAI. This is probably the one that is most advanced and has the most usage. And OpenAI is also the company that offers ChatGPT. So all of the machine learning functionality that is built into ChatGPT is also built into DALL-E 2. So I think those are the three that I referred to.
Thank you, Phil. Um, and if you want to learn with any of these softwares, Revit, Inventor, or Fusion, you can always take a custom training with Phil or someone else on our team. We also offer group classes online, and we have upcoming up next on June 1st from functionality to implementation, Autodesk Docs, what's, how's, and why's. That one is going to be very interesting. And then on June 8th, we have why are users choosing Inventor over SolidWorks at 1 p.m. Um, so yeah, thank you so much, Phil, for that presentation. That was wonderful. Here you have our contact numbers. If you have any question, please don't hesitate to contact us. And so yeah, be sure to be checking the MicroCAD website for future webinars. And that concludes our webinar today. Thank you, Phil, and thank you everyone for attending. Have a great day.
Thank you for your time.